Hello. This lecture will talk about analysis of beam and frame structure for beginners, which is about how to determine the beam internal force. Examples will be given. For truss structure, you could refer to my previous video. Remember to subscribe to my channel, and more information related to civil engineering, structural engineering, and foundation will be provided. Your subscription is important for me to continue making videos. Please subscribe to my channel. Thank you. In this video, we'll take a detailed look at beam and frame structure. Beams or frames are one of the structures for those new to engineering will tackle. The reason for this is beams or frame structure are a very commonly used structure. In this video, I am going to demonstrate how to determine internal member force of a beam member. For determining shear force diagram and bending moment diagram of a beam or frame structure, please refer to my another video. To begin with, it is important to know about beam or frame structure. A structure that is made up of slender members, connected at joints which are in pinned connections, is a truss structure. In theory, the pinned joints provide no rotational resistance and behave as hinges. As such, moments cannot be transmitted from one member into adjacent members. Only axial forces can be transmitted through nodes. However, it is a totally different story on beam or frame structure. Members can be connected in pinned or fixed support, and members carry axial, shear force and bending moment. Therefore, the internal force of the member in beam or frame structure may vary along its parallel axis, as shear force may be applied on beam, which lead to moment vary along the beam. These diagrams present the shear force and bending moment diagram of the beam, which show that the bending moment and shear force along the beam is not constant. I will demonstrate this example afterward. The concept of this slide is bending moment and shear force along the beam may not be constant, as the connection between beams can be pinned or fixed. This slide shows the concept on which fixed connection provides rotational restraint on beam, and moment is transferred from connection. Let's start our lecture. The first thing in this chapter is how to determine internal force. As the beam is in a state of static equilibrium, the three equations of statics can be applied and help us to solve for the internal force of the beam. It is required to cut the beam into two segments at the point we are interested in, and use the three equations to solve for the internal force. A simple example is demonstrated. Cantilever beam with fixed support, and a 2 kN load is applied at its end. If I want to find out the internal force of the beam at the location of the middle, it can be done by making a section cut in the middle, and the internal force is found as shown. To be more clear, I will show a step-by-step procedure of finding the internal force of a beam. First, calculate the support reaction of members. For example, it is necessary to calculate the two support reactions before we have a section cut. The next step is keeping all distribution load in their exact location. Then, make a section cut at the location in which we are interested in its internal force. Like this. If we want to find the internal force of this member at the location L, then we make a section cut at the location of L. The next step is that a free body diagram of the member segment is drawn, and we can start by solving the member with the least no of load. Like this example. After cutting the member into two segments, we can draw the free body diagram of them and also indicate unknown resultant force N, V, M acting on them. Like this example. An unknown internal product is produced in the beam member due to the loading. The last step is finding the unknown internal force N, V, M by using the three statics equation. These are the steps of finding the internal force of a member. Let's start with an example. A beam which is 10 m long with a 2 kN, m loading added on it. Find the internal member force at location L, which is for m apart from support A. First, let's determine the support reaction. Make an imaginary cut along it as shown, and also indicate unknown resultant force N, V, M acting on them. Then, use the three equations to solve for them. As the structure is in static equilibrium, the sum of force in x direction is equal to 0. Therefore, N is equal to 0. Next, I am going to solve for the force V. As the structure is in static equilibrium, the sum of force in y direction is equal to 0. The support reaction is 10 kN, and the downward load is 2 kN, m which is 8 kN in 4 meters. After solving for it, Its value is 2 kN. As it is a beam structure, moment is transferred along it. As the structure is in static equilibrium, the sum of moment of any point is equal to 0. Take moment about point C. The support reaction equal to 10 kN, and its lever arm equal to 4 meter. Also, 2 kN per meter of loading is added on beam. Therefore a sum of 8 kN load is added, which its lever arm is 2 meter. The sum of this two components plus a moment m should be equal to 0. Solving for m, we can get m equal 24 kNm. Therefore, we can get the internal force of beam at the location of 4m apart from support A.
Thank you for watching. It gives me a huge support and motivate if you would subscribe to my channel. There are further information related to structural mechanics, foundation and anything related to civil engineering in the future. Remember to like this video and I would feel great appreciation for your subscription to this channel.